Okay, this is Math 2, Unit 7, Lesson 1. Before we begin, I would really encourage you guys, if you're struggling with the radicals and how to work the radicals and simplifying them, to go back and watch the video called on Pre-7 in your grid called Simplifying Radicals. It's on our YouTube channel, so you can watch it there as well. And that will go through how do you work with radicals, because you're going to have a lot of radicals in this sheet and the ones to come. So make sure you're comfortable knowing how to use them there. All right, to begin with, we got number 2, looking at basically the Pythagorean Theorem and its converse today. Pythagorean Theorem, as you remember, is a squared plus b squared equals c squared. That's what we're working with for the most part for this whole worksheet. So it's a lot of plugging numbers in and trying to work to solve and work towards a solution. So for number 2, I have an a squared and a b squared. My c squared is always my hypotenuse. That is the one across from the 90-degree angle. So with this equation here, I have an a squared, I can call it my short side, 24 squared plus 45 squared will equal x squared. So that's my setup for this problem here. A squared, b squared equals c squared. At this point here, you can use a calculator, whatever works to help get you through it. 24 squared is 576 plus 45 squared is 2025. I know that's still going to equal x squared, so I'll have a space. I'll squeeze it in there, x squared. When I combine 576 and 2025, I get 2,601 equals x squared. To get the x by itself, what I'm going to want to do is take the square root of both sides. And so the square root of 2,601, you can see here, I have no idea what it is. So I use my lovely phone. I'll type in 2601 and I'll hit the square root button and it says that it is, 51. So x equals 51. And that's it for number 2. Alright, numbers 5, 6, and 7 want to know, does it form a Pythagorean triple? Pythagorean triple, if you remember from your workbook, there's a few of them they give you, and one of the most common ones is the 3, 4, 5 triangle. Basically what that means is that, hey, this squared plus this squared equals that squared. If it works out smoothly and easily, then you have a right angle, and it's a Pythagorean triple. So what you might want to do to see if this is the case or not is you could take a look at a question like number 6, and we can go ahead and take those numbers and we can just work it out. 7 squared plus 16 squared, and we set it equal to 18 squared, and we determine, is that true or is it not? 7 squared is 49. 16 squared, which comes up a lot in these problems, so you might want to make a note of this here. As I worked through it, I saw 16 squared several times. Kind of good thing to look at is you have 18, 18. The same type of numbers get used a lot in math problems. Down here, number 14, we have the number 18 and 16. So you might want to make a note of what those are because, hey, it comes up again. So rather than doing it 1,000 times, just make a note. 16 squared is 256, and 18 squared is 324. So if this is a Pythagorean triple, then 49 plus 256 will equal 324. Well, sadly, 49 plus 256 equals 305, and that does not equal 324. So we would say no for number 6. It is not a Pythagorean triple. Okay, number 8. Moving down to same idea, but now it says write your answer in simplest radical form. So again, if you're not sure about the radical part, this is where you could trip up a little bit here. I have a 4, I have an 18, and I have an x. So to solve this problem, I'm going to go ahead and write it over here to the side here. I have, this is my hypotenuse there, I have a 4 squared plus x squared is going to equal 18 squared. Looking at the 4x and the 18. 4 squared is 16 plus x squared. 18 squared, I look up above because I've already used it here, is 324. So I'm in good shape so far. I want to get the x squared by itself, so I'll subtract 16 from both sides. X squared is now going to equal 324 minus 16, which is 308. At this point, you have to have your own way of doing this here. The way I do it is basically look first of all for the even numbers. Can I divide it by 2 to get something smaller that's more manageable? I can see that 308 can be broken up into 2 times 154. Now 154 is still even, so I'm guessing I can break it again into 2 times a 77. 77 can be broken apart if I wanted to into a 7 times 11. Now I have some prime numbers here that I'm looking at. So when I see a pair of numbers, 2 and a 2, I know that when I take the square root of both sides, if I have a pair, that becomes a single number on the outside of my radical. And then I have to look at what do I have left. So x is going to become equal to, because the square root of x squared is x, equal to, well, 2 and 2 is actually a 4, but the square root of 4 is 2 on the outside of the radical. Underneath the radical still, I still have this 7 and 11. I can't do anything with it, so really it just stays the 77. Or I can multiply them back together, 7 times 11. So my answer for number 8 ends up a little weird, but that's okay. We're going to have a lot of these. X equals 2 radical 77. Okay, let's take a look at number 12. We have an a squared x times b squared 3 equals c squared 6. Okay, let me just write them over here for you. So we have x squared plus 3 squared equals 6 squared. So again, I have multiply this out or square it out. I have 9 equals 36. I'm going to go ahead and subtract 9 from both sides, and x squared is going to equal, in this case here, 36 minus a 9 is 27. 27 may not be a number that I can quickly say, oh, I know what that's going to be, but I know that 27 is 9 times 3. So when I do the square root of both sides, square root of 9 and times 3, I know that the square root of x squared is x, the square root of 9 is 3, and the square root of 3 is just simply still square root of 3. I can't do anything more with it. So when I break 27 apart, I end up with a 9 and a 3, square root it, and I'm left with x equals 3 root 3 for number 12. Let's take a look at one word problem real quick before we move on to the back side. It's good when you're looking at a word problem to probably draw a little picture so you know what you're talking about. It says a window washer has an 18-foot ladder. So I know I have one set of numbers there, 18-foot ladder. He needs to reach the bottom of a window that is 16 feet off the ground. So he has a window. Here's my window. I'm going to draw a little house here. Isn't that a lovely house? He has a window. There's his window. And the window is 16 feet off the ground. So from here to here, 16. Lovely. Now his ladder, we said, is 18 feet. Question though, before I go there, is how far out from the building should the base of the ladder be? We're going to have a ladder that we're going to stretch out to here, onto the ground. Here's my ground. We know the ladder is 18 feet. There. And the question is, how far does the ladder have to be from the window base in order to reach the bottom of the window and not make you fall? So we have a right angle that occurs right here. So this is what my triangle looks like. Because I have a triangle with a right angle, I know I can use the Pythagorean Theorem to solve this. And what do you know? I have again the 16 and the 18 numbers. So to work this out, I have x squared plus b squared equals the number across from my right angle, my hypotenuse, 18 squared. So this becomes x squared plus 16 squared above was 256. 18 squared above was 324. I subtract 256 from both sides to find out that x squared equals 68. Okay, I'm going to move this over here real quick. So x squared equals 68. 68, I may not know how to break that apart right away, but I know it's even, so I'm going to break it into a 2 times a 34. I know 34 is still even, so I can break that into a 2 times 17. 17, can't break that up into anything I can think of. So when I do the square root of both sides, square root of x squared is going to be x, and the square root of 68, this mess here, I have a pair, so that gets to go on the outside as the number by itself, and I see what's left is root 17 for number 14 there. So good to draw a little picture if you can, so you know what parts you're working with and which one's going to be your hypotenuse and which ones are just going to be your legs or base. Okay, on the back side, we're looking at number 17 and 20 and 21. For the first one, 16, 17, 18, it wants you to decide, is it a right triangle, and explain. So to figure this out, what it's wanting you to simply do is to take a look at your numbers, 27, 36, square them, and see if it's equal to 45. That's the whole idea behind these three questions here. You take the numbers, 36 squared plus 27 squared, and you decide, is it equal to 45 squared? If these are equal, then the answer would be yes. If they're not equal, then the answer would be no. So, in our case here, 36 squared is 1,296. 27 squared is 729. 45 squared is 2,025. So now I do some addition. 1296 plus 729. So 729, I add that up there, equals 2,025. Does that equal 2,025? The answer is yes. So this is a right angle. Now I explain that by saying yes, it's right angle because the two sides, when squared individually and added up, equal the square of the hypotenuse. So I know that I indeed have a right angle. You do the same for 16 and 18. If they don't equal each other, then you say no. Simple as that. Okay. The next one. Here we go. This is an interesting one, and I watched the videos that didn't really talk about how to solve this. So I worked through this to see what were the patterns that I was seeing with the answer key, and here's what I came up with. Right? If a squared plus b squared equals c squared, if that's the case, then you end up with a right angle. 90 degrees right angle. Okay? If a squared plus b squared is less than c squared, then we end up with an obtuse angle. And then, if a squared plus b squared is greater than c squared, then we have an acute triangle. And if you use these three formulas here, and then use the numbers they give you, that will help you determine if it is indeed acute, right, or obtuse. And that's all that they're really asking you to do. So I'm going to use the space I have down here. Look at number 20 real quick. I set it up this way. I said 9 squared plus 11 squared. I'm not going to say equal, less than, greater than, I still don't know yet, is something to 16 squared. Hey, there's that lovely 16 again. So 9 squared is 81 plus 11 squared is 121 is something to 16 squared, which once again, look back in my notes, 16 squared was 256. 256. I add these together, so 121 plus 81 is 202, and here I have 256, and when I look at those, I say, 202 is less than 256, and because it's less than, I look at my little cheat sheet up here, I know that it is obtuse. And that's what we're doing for those problems there. Let me show you one more real quick. I'll do number 21. We have 4 squared plus 6 squared is going to be equal, less than, greater, I'm not sure, to 7 squared. 4 squared is 16, 6 squared is 36, something to 49. 36 plus 16 adds up to 52. And 52, when we look at these things again and again, is greater than 49. So because it's greater than 49, we're going to say that this angle this triangle is acute. That's the idea there. You do the same thing for the remaining problems, okay? And then down the open-ended, you're going to come up with your own numbers. So think of your own numbers that when you multiply, you can get this kind of situation, and use this as your directions to make sure you're doing it the right way. Okay? And that should help you get going to the rest of them, and the rest kind of work your way through. Thanks.